Everyone, welcome to Big Data Thoughts. Today we are going to talk about supervised learning. In the previous videos, we have spoken about what is artificial intelligence, machine learning, but today we are going to focus on supervised learning. What it is, what are the different types, the advantages, disadvantages, and applications of it. So, first of all, what are the different types of learnings that are available? There are broadly four categories: supervised, unsupervised, semi supervised, and reinforcement learning. We will look into each of those, but today we'll specifically talk about supervised learning. So, what is supervised learning? It is definitely a form of machine learning in which the whole machine learning algorithm is built on a labeled data set. So, in the previous video, we saw that there are two types of data sets that are used to build a machine learning model. The first being the training data set on which the model is actually built. Then comes the validation data set, which is used to see whether the model we have built is accurate or not. Now, when we talk about the training data set, if we want to build a supervised learning algorithm, that training data set will be a labeled data set, which means it will also have the output data. So this labeled data set will have both input as well as output, which means for example, if we are doing a fraud detection and we want to build an algorithm to detect fraud on the transactions, the training data set would actually contain transactions from the past where the output is also there. So there are a set of attributes on which the model will be built, and there is also the output. So it tells you that okay, whether this transaction was fraudulent or not. So that labeled data set becomes the basis of building the supervised learning model. There is definitely a mapping between the input and output data. For every transaction, we do have the output also. So we are telling the machine that this is the list of transactions we are feeding in as a training data set. It also has the output. On that, the machine builds the machine learning algorithm is built. So the mapping is learned from the label data set. It contains both input and output data. The algorithm that we are building will try to learn the relationship between the input and output to make accurate predictions when we feed it the actual data. So this training data set will have a number of attributes. For example, the customer, the date of purchase, or what was the what purchase was done, all of that, which has nothing but the features on which the model will be built. It also has the output, which is the prediction, a yes or no probably, or just talking about whether it was a fraudulent transaction or not. Now, since it is labeled, it has an output. This is known as a supervised learning, where we are helping the machine to build the algorithm by giving the output also in advance in the training data set. Now, let's talk a bit more about supervised learning. So this is, like I said, the model is trained on a labeled data set. A label data set will have both input and output parameters. Now, both the training data set as well as the validation data sets are labeled in case of a supervised learning. Usually, when we train or build a machine learning algorithm, it is a 80-20 ratio, which means 80% of the data we collected is used as a training data, and rest of the 20% is used for testing or validation. We will key in the 80% of the data while building the model. Once the model is built, we will validate it on the 20% of the validation data. But here for supervised learning, both training and validation data sets are labeled, which means it has both input and output. Also, when do we use the validation data set? Training data set is used initially to build the model. But once it is built, we want to understand whether the model is accurate, is it predicting correct results or not. That is when we use this validation data. And since the validation data set is also labeled, we know the output. We can look at what output the machine produces and compare it with our validation data set output to see the accuracy of the model. So that's how our training and validation data set would be used for a supervised learning model. When we talk about supervised learning, it can also be divided further into categories. Broadly, very high level, there are two categories that we have under supervised learning. One is regression, the other is classification. And if you are into the space of ML and you've started your journey, you would have definitely heard about regression and classification. So these are nothing but type of supervised learning. In regression, what the model does, it predicts the value which is a continuous value, such as price of a house or temperature of a city. So these are continuous values. Whenever we talk about regression kind of supervised learning, of course it is on a labeled data set, but the output, depending on what output are we producing, we determine whether it is regression or classification. If the output is a continuous value, a temperature, a price, or those kind of things, it is a regression kind of supervised learning. Classification is very binary, where we predict a categorical output, such as whether the transaction is a fraud or not, a yes or no. It's a categorical value. Whether the customer will purchase something, yes or no. Whenever the output is of a categorical nature or kind of a yes and no, it is a classification. We are just classifying, saying whether it will happen or not happen. Whenever the output is much more than categorization, where we have a continuous output value, it is regression. So what is the primary advantage of using a supervised learning? It can actually help to create complex models and make accurate predictions on new data. Why? Because both our training and validation data sets were labeled, so we know the output well in advance. It is easier for the machine to it is easier to build that machine learning algorithm because you already know the output, it is labeled. So you can build complex algorithms or models that can accurately predict on the new data. But definitely the prerequisite here, and for any machine learning model or any kind of learning model, is that the data on which we are training or validating has to be of good quality, which is obvious. If the data is unbiased, of good quality, and a bigger sample set, as in it covers all the different kinds of scenarios, the model will be more accurate. So the quality and the representativeness of the training data will have a significant impact on the accuracy of the model. Quality we all understand. What is representativeness? Which means how many scenarios is it covering? Whatever is our goal, if we want to predict whether the transaction is fraud or not, the data we have collected should cover as many scenarios or representativeness from the population, which means different kinds of transactions that have happened. If we can collect more and more of those in our training data set, the model will be much more accurate. Now let's talk a bit more on regression and classification. So regression, as I mentioned, is a supervised learning technique where the output, it's all based on the output, whether it is regression or classification. If the output is continuous numerical values based on the input features, it is a regression type of learning. What is the aim here? The aim here is to establish a functional relationship between independent variables and a dependent variable. What does that mean? If there is a data set which has, let's say, 20 attributes, right? And I'll give an example, but let's say there are 20 attributes, we call them features. So these are independent variables. For example, if we are trying to predict a house, price of a house, so what are the features here? The size of the actual flat or house, number of bedrooms, the location, where it is located. These are all independent. The size of the house is not dependent on the number of bedrooms or the location. These are all independent features which are used to predict a dependent value. Dependent value is nothing but the output. The output is definitely dependent on where the house is located, what is the size, the number of bedrooms, all of that. So these input features are all independent, but the output is very much dependent on the input. So regression is doing what? It is trying to establish a relationship between the independent and the dependent variable. For example, if the number of room increases, how it will impact the output or the price of the house? the price of the house will increase. If the location is at a very good location, upcoming location, the price will vary. So these input variables are independent, but the output is dependent on them, and that relationship is established by our regression kind of supervised learning. The goal here is to minimize the difference between predicted and actual values. So whatever output we are predicting, that should be as accurate as possible. The difference between the actual value and the predicted value should be the minimum. So different types of regression algorithms are linear regression, decision trees, neural networks. These are all different types. So within machine learning, there is a category called supervised learning, where both dataset, training and validation are labeled, which helps us to predict the output. And supervised learning can be classified broadly into regression and classification based on the type of output we are trying to predict. If it is a continuous numerical value, it is regression, and there are different types of regression models that we can build, like linear regression, decision trees and neural networks. So that's how the hierarchy is. Coming to classification. Classification is also supervised learning type, but here we are categorizing the input data into predefined labels. So what is happening here? For example, we want to classify whether the transaction was fraudulent or not, one more example is whether the email is a spam or not. So it is a categorization, yes or no. The goal here is to make accurate predictions on the new unseen data. Once you train the model, build it, validate it, you want to predict. The prediction should be as accurate as possible, or the difference between actual and predicted value has to be minimum. That's the whole purpose of any machine learning algorithm. The only difference here is we are doing a categorical output. The examples for this can be again neural networks, vector machines, decision trees. These are commonly used for classification. Okay, what are the advantages of supervised learning or having labeled data set? So it helps us to build more accurate models, or learn patterns and relationship between input output easily, because the output is also given, it's a labeled data set. It can accurately predict and classify new data because you have trained it on labeled data. It has a wide range of application, including classification, regression. You can build complex problems. You can solve complex problems like image recognition, natural language processing. Like I said, NLP is a supervised learning model. There are well-established evaluation metrics, including accuracy, precision, recall. We will talk about these in separate upcoming videos. What is F1 score, then what is precision, how do you predict the accuracy. Okay, but overall, the advantage is here you have a labeled data set, so you can build complex models more accurately. The disadvantages is overfitting. The model can overfit training data, which will lead to poor performance. What does it mean? Since it is labeled, sometimes we do a overfitting of the model, right? On the training data is labeled, we have the output, so the model kind of becomes overfitted, which means if the model becomes overfitted, the accuracy of the model will be lesser. Right? The feature engineering part, extracting relevant features from the data, is crucial, because if you have a data set which can have 100 features or attributes, but out of that, which attributes are actually affecting the output is what we need to pick up as input to build the model. Now that is known as feature extraction. These attributes or columns or different values that are present in the data are called features. These features are very, very crucial, because you won't select all the attributes, you will select a subset which is going to influence the output. And this whole process is crucial, and it can be time consuming. And of course, this will require domain expertise to select the features. Sometimes if there is a bias in the model, now this is not exactly just for supervised learning models, but it is also applicable to any model where if there is a bias in the training data set, or we have done a very small sample, or the data has been picked up from a very small sample of scenarios, it will be biased and it will have unfair predictions. Okay. One thing to remember is that supervised learning heavily depends on the label training data. Now, labeling the data or getting a labeled training data is also costly and time consuming. It may require, of course, domain expertise. So that data set is very, very crucial, and the labeled, since it is labeled data set, it needs to be really accurate, that the output is correctly given. Then only the accuracy of the model would be good. So it is the biggest time consuming activity for building any machine learning model is preparing that data on which model will be built. Okay. What are the applications of supervised learning? There can be multiple applications, but few of them are like handwritten digit recognition. There are handwritten notes. Now, how do you recognize that? Doing sentiment analysis. By reading certain comments, posts, you determine what is the sentiment of the customer, let's say. Doing medical imaging, credit scoring, the entire credit card transactions. When the credit card transactions are looked at, a person's credit score is calculated, which is used, you would see seldom in giving home loans or personal loans or whatever kind of loans. You look at the credit history or the credit score of a person. That can be done using supervised learning. Spam detection, like we spoke about email spam detection, we can do that. Fraud detection, these are all classification kind of, where we are doing spam detection, fraud detection. But something like sentiment analysis or credit scoring, these are regression type of, where you have a continuous numerical value. So these are some of the applications of supervised learning. I hope this video has given you a brief introduction to what is supervised learning and what are regression and classification as a concept. We will look into more detail into example of how we build a supervised data model in the upcoming videos. So thank you so much everyone for watching. Please like and share and subscribe to the channel. Thank you.